everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we're going to be solving the problem Chef and Time Machine. The difficulty level for this problem is simple and prerequisites require are your multi-set data structure. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, so let us try to understand the problem statement. So basically, Chef spent 10 days working really hard. He planned loads of tasks, as many as AI tasks to do on ith day, and Chef's work was brutal, so he only managed to finish BI tasks on ith day. The good news is that Chef has a time machine. The time machine has K white buttons and M black buttons. Each button has a positive integer printed on it. Now, Chef goes through all end days consequently and presses buttons. Each day, Chef can press only one button, either white or black. After using a button once, it becomes inactive. Pressing a white button with integer x printed on it reduces the number of planned tasks on the day, and it was pressed by exactly k. Note that this white button can only be pressed if number of planned tasks on the day are greater than equal to x. Pressing black button with integer x printed on it increases the number of completed tasks on the day as it was pressed by exactly x. And note this black button can be pressed if after pressing it the number of completed tasks doesn't exceed the number of tasks. Now Chef is interested in finding the minimum possible amount of total uncompleted tasks that he will be left after completing or after n days using time machine in the best possible way. Be careful, Chef. Time is sensitive. Chef cannot make a day when he completed more tasks than he planned, as this may result in a work more than planned paradox, killing all the lazy people in the planet. Okay, let us try to understand the problem statement. So basically, in this problem, firstly, we are given my n working days, and in each working day, I am given my A1, A2 up till AN. Each AI generally denoting the number of expected tasks that were supposed to be completed on that particular day. Then similarly, I'm given my B array, which is B1, B2 up till Bn, and each Bi denoting the number of tasks that were completed on that day. So these are the expected tasks that were supposed to be completed, and these are the tasks that were completed. Okay. Now the question has given me also that it has given me my K white buttons and my M black buttons. So there will be another array say C1 C2 up till CK, and there will be another array say D1 D2 up till DM, right? So these are my buttons, and each particular button has an integer listed on it. Now what my button does is, firstly, I can use my button only once. So say if I use C1, I cannot use that particular button again. Then my each particular button on my any day I can choose any button, and the button has the following properties. So firstly, if I choose my C1 or any buttons from the C array, what happens is I can reduce my any day whichever A I choose. So basically if I choose my C1 button on say day A1, my A1 will be reduced by A1 minus C. So firstly, there should be two conditions that hold, that after the reduction, my A1 should be greater than equal to B1, because according to this paradox, that chef cannot make a day when he completed more tasks than he planned. So therefore, that tasks that were planned on that day should be greater than or equal to the tasks that were completed. So we can reduce it, and yeah, so A1 can be reduced to A1 minus C if I A1 minus C1 if I picked C1 button on A1 today. And if I use C1, then for the following days I cannot use C1 because that button is used. Similarly, if I use any D button, so what I can do is I can increase the tasks that were completed on that particular day. So say I use D1 button on my B2 day, so my B2 will become nothing but B2 plus D1. But again, this particular condition too should hold, that my A1 should be or nothing but my A2 should be greater than equal to B2 if I use this particular task, because otherwise it will be a work more than paradox, right? So we don't want to violate that condition. So this is what the question is asking. Okay, so in the question, it is asking that find the minimum possible amount of total uncompleted tasks that he will still be able to left, so he will still be left with n days after using the machine in the best way. So basically, in this question, we have to minimize the total uncompleted tasks. So what does it mean by that? So as you know, these are the tasks that were planned and these were the tasks that were actually executed. So we can basically, so the difference between them, which is A1 minus B1, were the tasks that were left, right? So tasks that were uncompleted. These were the quantity. For any generalized, say my AI minus BI is the tasks that were left uncompleted. So how the question is giving as option either to decrement the value of AI or to increment the value of BI, right? And this is how we can reduce our tasks uncompleted. So let's see. So this is what the question is asking, and let's see how we can approach this particular problem. Okay, now let's try to approach this particular problem. As you can see, we are given my two arrays A and B, and also take the use of the sample test case to understand the approach for this problem. Okay, now consider what is my firstly total uncompleted tasks. So for any generalized I, my total uncompleted tasks are nothing but my value of AI minus BI. And then total, that means the summation of entire array, right? So this is my total or uncompleted tasks. Now, what the question is saying is we are given buttons. So using the help of buttons, what we can do is either we can decrease the value of AI or increase the value of BI so that we could minimize this particular expression, right? So what can we do? One basic observation that you get is, firstly, it doesn't matter whether my whether my white button is present or black button is present, because since I want to minimize the difference, whatever the difference is generated, I could simply use it in BI if it's a black button or use it in AI if it's a white button. So let me just demonstrate what I'm saying using this sample test case. So basically, let me generate the differences between the elements. So firstly, 5 minus 3 is 2, then my 7 minus 3 is 4, my 6 minus 1 is 5, and my 1 minus 1 is 0. So this is the current answer if I could not time travel, and if my 4 plus 5 6 and 6 plus 5 11. So initially my answer would have been 11 if there was no time travel. This might be the incomplete tasks. But since I can time travel and I can reduce the time, what I'll do is consider my buttons as 6314. So I have my buttons as 6314. So on the first day, what I can do is I can select a button which is just smaller than 2, basically button 1. And as you know, button 1 is of type D. So in my initial configuration, what I've done is I'll use this one button to increase the value of 3 by 1, so which will result in 4. So 5 minus 4 would equal to 1. Or in other words, I'll choose the button which is just less than the 2 in the differences array. I can choose a button which is just less than 2, and yeah, this one button less than, and we can just subtract that particular button to get our 1 in the reduced array. So this is we reduce the task, or we minimize the uncompleted task by remaining 1, right? So I subtracted 1 from this particular case. Similarly, we can do it for this following thing, that I have my 4 tasks remaining. Now I can choose a button which is just less than or equal to 4, and as you can see I have a 4 button here. So in my initial array, this is also a type T button. So my initial array had 7 completed tasks, or 7 tasks that were expected. My 3 tasks were completed on that day, so I can use this button to make this 3 as 3 plus 4, which is 7, and then 7 minus 7 would result in 0. Or in other words, my 4, my less than 4 or element which is just less than equal to 4 is 4 itself. So 4 minus 4, so 0 tasks left on that day. Similarly, for 5, I cannot choose any button. So currently it is 5 only. No, sorry, for my 5 I can choose. So for 5, what I can do is I can choose the button 3. And as you can see, my 5 minus 3 will be nothing but 2. And then for 0, I cannot choose any button because no button is less than or equal to 0. So this becomes my final configuration. And as you can see, the total uncompleted task is nothing but 1 plus 2, which equals to 3, right? And this is the answer for this particular test case. So our approach for this problem becomes simple. What we can do is we can just keep my entire A, or what I can do is I can keep my buttons, which is nothing but 6314 or whatever buttons array, I can keep it in a multiset. So in multiset, as you know of C++, my elements will be in sorted order. And why I said multiset? Because there can be multiple buttons with same values. So if I considered any normal set, my duplicate will be removed. But since I want to consider buttons as uh, duplicate entities also, I have to use multiset. And yes, the approach becomes simple. We can use a multiset data structure to store these elements in a sorted array or a sorted fashion. Now, for every element, I'll generate my difference array. So I'll generate my ai minus bi array in this case, and then for every particular integer, I have to choose the button which is just less than or equal to that particular button. So for 2, I can just simply lower bound the value of 2 in my multiset to find the element which is just less than equal to 2 and find that particular element. Similarly, for 4, I can do the same thing, find the just less than equal to element in the multiset and get a required answer. And after doing so, the final array we generated, we can just simply take the sum of that array, giving us the answer of our uncompleted tasks in that particular day. Also, the total uncompleted task that will be done after n days after taking the sum of array. So yes, this becomes the approach for solving the problem. Now let's see how we can code this particular approach. Okay, now let's try to understand the code for the following problem. So here we include all the necessary header files. Then for my main function, I firstly write my t-test cases and input my t-test cases. For each test cases, we input my nkm according to the input format. Now we initialize my four vectors, which is n, my an, bn, ck, and dm, as I discussed in the approach section. Then we input each and every vectors according to the input format. Then simply I generate my difference array, or firstly I can compute the result, or this is the current uncompleted task. So basically if there was no time travel, then this would be my answer. Then simply I initialize a multiset S as I discussed in my approach section, right? Then we take the buttons array and we insert the number into the multiset. Then for my I traverse in my n, I generate the difference of that particular array, and then here we pick the smallest element which is just less than equal to that particular element, so which is just less than equal to that difference. So I search for that element in my multiset, and if I find that element, I remove it from my result because my uncompleted tasks will be reduced by that much percentage, and then I simply erase that particular element from the multiset because that button was used. And after traversing for this end loop, we have our answer as the result, right? Now let us run our code on the sample test cases to see whether everything is working correctly or not. So as you can see, we got the correct answer for the sample test cases. Now let us run our code on submit on the actual test cases to see whether everything is working correctly or not. So as you can see, we got the correct answer for the following problem, and yes, this becomes the valid approach for solving this problem. Now let us discuss what people could do wrong in this particular problem. So firstly, the use of multiset was most important in this question because multiset has a time complexity of log n for insertion and removal. So whenever we are removing the buttons after it was used, the time complexity of removal is log n. People could, if the people did not use multiset data structure and use any kind of brute force removal technique, then they might get a time limited exceeded error if their approach was also, even if the solution was right, but due to time limit exceeded error, they would get a wrong, they would get a TLE verdict, right? So that is one thing that you should make sure that whenever you can use or you can optimize your runtime using an inbuilt data structure, you should try to do it. So this is the learning you get from this video. And yeah, apart from else, I don't think anywhere else if the logic and the implementation was clear, a person could not make mistake in syntactical. So the chances of that happening are quite less if the logic is clear. So yeah, I hope you like this video. Please like, share and subscribe to the channel. Thank you.